And we're rolling. Okay, ready, set, go. We're doing Whodunnit, Harry Watson, February of 2025. If is number on this one. So if it's a number, then we want to return the unichar, otherwise the Unicode. And that's good. So the same thing, I think they expected me to use char encode here and then use Unicode unichar here, but it's already solved. Don't need to do anything different. Okay, now we're shifting the characters. So, first off, I want to convert this into, let's see, what do we have to do here? Equals Unicode of this 67. And so I want to subtract 64 to get its position. I'm going to then add the shift. We need to mod to make this reverse around, wrap around the characters. So we're going to subtract 1, mod by 26, and then add 1 back. And now add our 64, turn this back into a character. Like so. Okay. And in doing that, we can turn this into a lambda, and we'll just call it char shift. So given these two as inputs, save lambda, save it as char shift. Now when we get to this, we're going to say mid. We'll need a sequence. The length of this 1. So split that into letters, and we'll map that against char shift. So V is our letter, shift is here. And then we concatenate the results. Okay. So we'll call this word shift. Mark those as inputs. Save this lambda. Okay. Here we go. Figure out what the shift is. Leave numbers and spaces as they are. Everything starts with the day of the week. So that's what the day of the week is supposed to be, which means the rightmost character of this, that's supposed to be a Y. So the Unicode of that minus the Unicode of Y is what our shift is. That's our shift. Okay. And so now we need to word shift this. Actually, let's just say equals, let's see, here's our last word, equals after the last space, using the -1 for instance. And then our answer would be word shift of that word, I think we want negative probably. We want negative for the shift. So that's our answer there. So okay, so in this one we have an along shift, which shifts every single character in an increasing manner. So the along shift is based on the day. So we're going to XLOOKUP the day of the week, anchor those, anchor these. So our along shift is 2. Our ordinary shift is figured out by looking up the recipient and sender in this table here. So I'm going to create a table out of this, call it T, and let's rename this column here called recipient. So we have senders along the top and recipients along this side. So the intersection of the sender and recipient. So we want to say XLOOKUP the recipient in T recipients, returning T, intersected with XLOOKUP the sender in T headers, returning T. So that's the ordinary shift. Alright, now mid sequence length G235. So those are our characters. Now we wrap that with Unicode to get our starting values. We're going to add our ordinary shift to each of those. Okay. And then we're going to add our along shift, which is formed by a sequence. So we're going to start at 0, and step is going to be the along shift number. So those are our final encrypted values. Turn them into characters, Unicode characters, and concatenate the results. Good. Okay, level 7. We've intercepted 30 messages. These messages are here. Each of these messages reference a crime that was committed. So we'll call this e-message for encrypted message. We'll turn this into a table. And just like before, it starts with the day of the week. Of course, it's encrypted within a long shift. So the encrypted day of the week, E-day, is everything before the first space. Alright. Now, the rightmost character of that is supposed to be a Y. So equals right. So that's the Y. And the A is the left of the right 2 characters here. So that's what's supposed to be the A. Let's Unicode both of these. Okay. Now, normally there's supposed to be a difference going from A to Y. There's supposed to be a Unicode difference of Unicode Y minus Unicode A. So there's supposed to be a difference of 24. The actual difference is 28. We're going to subtract 24, and this is your long shift. Alright. Now, we know the long shift is 4, and so we're going to take this 10665, subtract what the long shift would be for the y of that position, and then also subtract the Unicode of y, and that's what the total ordinary shift would be. So this is what we're solving for now. Ordinary shift is going to be this minus the length of the day, which could be a different number of characters, minus 1, because our long shift starts at 0, times our long shift. So we've subtracted out the long shift, and we have to subtract out what the starting Unicode character of A is. No, sorry, Y. So that's our ordinary shift. Now, the goal is to find out who the murderer is. And the sender of this message is the murderer. So we have to figure out, based on what that long shift is, look it up in this table, and then look directly up to see who the sender is. That's the murderer. Okay? So what I'm going to do is look up by column. This would be T. So we're going to search for each column, and then say, is any of those values equal to our ordinary shift? If it is, then we'll get true. Alright. So what that's going to give is an array across basically each of these columns. And so if I filter the headers based on that true, we'll get the name of the murderer. So we'll say filter T headers by this true false array, and that is our sender. The last thing we need to do is be able to match up the crime to the person. So we know the person already, but the crime is embedded in this encrypted message. So we need to use our shifts to unencrypt this whole thing. So the original message is going to be something like, well, let's see. We didn't create a lambda that uses the shift, so I'm going to do it step by step over here. We'll say deconcat, equals mid that length that sequence length that and 1. So that splits them into characters. Here are the Unicode values. Okay. Now, one of the things is we're meant to ignore spaces and numbers. So I'm just going to say, like, if this value is less than 100, then keep that value, otherwise do the shift. So we'll say if that, let's use a let codes be that. So if codes is less than 100, codes, otherwise, what are we going to do to it? So we're going to take codes, and we're going to subtract ordinary shift, and then we're going to subtract a sequence that is the length of the message. It starts at 0 and steps along the long shift size. So that should give us an array of numbers that we can turn into Unicar and then concatenate it, and that will give us our full message. What do I do on there? So that's our message. So copy, put it in there. So the crime could be in different spots. So we're gonna have to look up the crime using a find or a search. And I'm just gonna put the day of the week in here equals before that. Okay, so now to find the murderer, we're going to basically say filter the sender's name. Where is number find? What are we looking for? We're looking for this crime in the message. If that's true, then return the name of the killer. Rachel. Good. Okay. Bonuses. Convert all the characters in level 1 and 2 to the Unicode, and then find the average, round to the nearest integer. Okay. So just a little helper column will say, if is number that, then give me that, otherwise give me the input. I have to do that for levels 1 and 2. And then come up here and just say rounds, average. So we're going to take the average of this column and this column, round it to 0 digits. Okay, what is the most common ordinary shift in levels 3 and 4? We usually use a lambda for this in competition, but I'm trying to do this video without lambdas. So it's good practice. 3 and 4, here's my inputs. We'll say equals vstack this and this. So here's all my inputs in one thing. We'll say group by, and we'll just want to count them, and I'll do some sorting. We're looking for the most stuff. So this is the value that is the answer, which is 1. Okay. On the correspondence tab, determine the Unicode characters of all the symbols. Okay, so just concatenate everything, find the Unicode. Okay, we can do that. So we'll say sum Unicode unit char. Then we want to deconcatenate, so we're going to say mid concat the whole message. This is the encrypted message. So we're going to concatenate the encrypted message on a sequence of length of the encrypted message. Did something on there. Okay, so what are we doing? We are we're splitting up this whole thing. So first of all, did this work correctly? If this worked correctly, we would be splitting. I think that worked. Okay, so then we're taking the oh, we want the Unicode. I don't want a Unicare. There we go. On the people tab, what is the maximum shift? Okay, so our people are here, and so they want to know so like the order matters, right? So if you're doing Benjamin to Amelia, it's 99.17, but if you're going Amelia to Benjamin, it's 98.75. And so 99.17 minus 98.75 is the difference between those two people. They want to know the max difference between any two people, and so that's going to be these values minus transpose of these values. And so if we put this into a call, to call and use ignore errors, that just gets all the values. So we're going to absolute value those. and then take the maximum. Paste that formula in. There we go. On which day did the most crimes occur and how many times it appeared? So we're going to do that with a group by. And so we'll say group by the day. And then just count them using count A. And so here's our top answer, Tuesday 8 times. So we'll say Tuesday -8. That's the answer. Pretty good for having no lambdas. I think if I had that mid-sequence decatenate lambda, probably save some time. Maybe have Cypher for doing the shifting would be a pretty common thing to have. But overall, pretty doable. There we go. Have a good day. I'm Excel Gladiator, and my goal in creating this video is to help people level up their Excel skills, as well as grow the world of Excel esports. If you want to help me do that, please like and subscribe, drop a comment, or check out one of these other videos.